For centuries, people have tried to define Indonesian identity. Is it Austronesian? Is it Papuan? Or is it something even more ancient, hidden beneath layers of history? The truth isn't in old texts or ancient ruins. It's written in our blood. DNA holds the answers to one of Indonesia's greatest mysteries. And what scientists have recently discovered is more shocking than anyone ever imagined. Indonesia isn't just an archipelago of islands. It's an intersection of civilizations. Its people are walking time capsules, carrying the genetic footprints of travelers, explorers, and survivors stretching back tens of thousands of years. But here's the surprising part. DNA tells us that no one is truly native. Instead, Indonesians are the result of a complex genetic puzzle, shaped by waves of migration from different parts of the world. The question is, who were the first to arrive? And how did their DNA shape the Indonesia we see today? To uncover the truth, we need to go back 50,000 years, before recorded history, before kingdoms and empires, when early humans first set foot on what is now Indonesia. These ancient settlers came from Africa, traveling through the now submerged land of Sundaland. At that time, much of Indonesia wasn't islands, but part of a vast landmass connected to mainland Asia. They were hunter-gatherers, living off the land, leaving behind only traces, until now. Through mitochondrial DNA, scientists have identified their genetic markers, proving their presence long before modern civilizations emerged. But these first settlers were only the beginning. Over thousands of years, new waves of migration reshaped Indonesia's population. The Austronesians arrived around 5,000 years ago, bringing advanced seafaring skills, agriculture, and a new language family that would spread across Southeast Asia and the Pacific. This was no small movement. These were some of the greatest navigators in human history, traveling thousands of miles across open ocean. Their arrival didn't erase the earlier populations. Instead, they mixed, creating a rich genetic blend that still exists in Indonesia today. However, there was something stopping them from spreading everywhere. A mysterious boundary, unseen, but deeply influential. The Wallace Line, a natural divide separating western Indonesia, where genes are linked to mainland Asia, from eastern Indonesia, where Papuan ancestry dominates. This explains why people from Sumatra or Java look genetically different from those in Papua or the Maluku Islands. Even after thousands of years, this invisible genetic barrier remains, shaping the people of Indonesia in ways few fully understand. But history didn't stop there. The rise of trade, empire building, and colonization introduced even more complexity. Indian and Chinese traders left their genetic imprints. Arab merchants and Islamic expansion brought Middle Eastern influences. European colonial powers, like the Portuguese and the Dutch, added another layer. Yet, through all of this, Indonesia's core genetic identity remained intact, a testament to its deep-rooted ancestry and resilience. Today, this genetic legacy isn't just a story of the past. It has real-world effects. DNA research is now helping scientists uncover health risks specific to Indonesian populations, such as genetic blood disorders like thalassemia. By understanding these genetic patterns, researchers can develop better medical treatments tailored to Indonesians, proving that DNA isn't just a record of history. It's a key to the future. Indonesia's DNA is unlike any other in the world. A mixture of ancient African travelers, Southeast Asian explorers, Austronesian navigators, and countless historical influences. It is a living map of human migration, a testament to survival, adaptation, and evolution over tens of thousands of years. And with every DNA study, we get one step closer to understanding not just where Indonesians come from, but where humanity itself began. 50,000 years ago, long before the rise of kingdoms, civilizations, or even the concept of Indonesia as we know it today, the first humans arrived. But who were they? And how did they get here? Science now confirms that these ancient settlers were among the earliest pioneers of the human race, leaving behind a genetic legacy that still exists in Indonesians today. The journey began in Africa, the birthplace of modern humans. As small bands of explorers ventured outward, some traveled along the southern coast of Asia, reaching the vast land of Sundaland, what is now Indonesia. But this region was very different from the archipelago we see today. Back then, Sundaland was a massive landmass, connecting Sumatra, Java and Borneo to the Asian continent. Sea levels were lower, and what we now call islands were once connected by lush forests and winding rivers. Archaeological discoveries prove that these early humans were already thriving in Indonesia tens of thousands of years ago. In Sulawesi, ancient rock art dating back at least 40,000 years depicts hand stencils and mysterious animals, suggesting a rich and complex culture. Meanwhile, the remains of early humans found in caves across Java hint at a long and unbroken presence of modern humans in the region. But DNA reveals even more. By analyzing mitochondrial DNA, scientists have traced the genetic markers of these early settlers. They belong to haplogroups M and N, lineages that connect modern Indonesians to some of the oldest human migrations in history. This means that Indonesians today carry the direct genetic heritage of those who first walked these lands, surviving and adapting for tens of thousands of years. But what happened to Sundaland? Around 18,000 years ago, the world began to change. The Ice Age was ending, and massive glaciers melted, causing sea levels to rise dramatically. The once connected land of Sundaland slowly disappeared beneath the ocean, leaving behind only scattered islands. This cataclysmic shift forced early humans to adapt, transforming them from land settlers into island navigators. They developed new ways to survive, relying on the sea, crafting boats, and becoming expert fishermen. This shift marked the beginning of Indonesia's deep connection with the ocean, one that still defines its culture today. Despite the loss of Sundaland, the genetic legacy of these first inhabitants remained strong. Even today, certain indigenous groups in Indonesia, like the Mentawai people, still carry genetic markers that link them directly to these ancient settlers. Their features, traditions, and even some linguistic traces serve as living proof of an ancestry that predates written history. The story of Indonesia's first humans is one of survival, adaptation, and resilience. Their journey was shaped by monumental environmental changes, yet they thrived against all odds. They were the pioneers of a land that would later become one of the most genetically diverse regions on the planet. And thanks to modern science, we can now piece together their forgotten story, one written not in books, but in the DNA of their descendants. 40,000 years ago, a vast and mysterious migration reshaped the genetic blueprint of Indonesia. It wasn't just one group of people. It was multiple waves of migrations, each leaving an indelible mark on the DNA of those who live there today. But how did these migrations shape the identity of modern Indonesians? And what secrets do these genetic imprints hold? The first great wave of migration came from mainland Asia. Hunter-gatherers, following the rhythm of nature, moved southward in search of food and new lands. They traveled across what was once Sundaland, a massive land bridge that connected Indonesia to the Asian continent. These early pioneers were resourceful, surviving in dense jungles and along vast coastlines. Their genetic markers still exist today, hidden deep in the DNA of some of Indonesia's oldest tribes. Then, around 5,000 to 6,000 years ago, a second wave arrived, the Austronesians. These were no ordinary settlers. They were master navigators, sailing from Taiwan and the Philippines, carrying with them a new way of life. They introduced farming, domesticated animals, and a structured society. Their impact was so profound that their languages still dominate Indonesia today. But here's what's truly fascinating. While they brought a cultural revolution, they didn't completely replace the earlier settlers. Instead, they intermingled, creating a unique genetic blend that still defines Indonesia's diverse population. But what about the Wallace Line? This invisible biological boundary, separating western Indonesia from the eastern islands, played a crucial role in shaping the genetic landscape. In the west, genes closely resemble those of mainland Asia. In the east, however, a completely different genetic influence took hold, one tied to Papua and Melanesia. Even though the Austronesians spread across Indonesia, they couldn't erase this divide. To this day, the genetic distinction remains, proving just how deep-rooted and resilient Indonesia's early populations were. And then came the unexpected, the migrations that history books rarely talk about. The spice trade, colonial rule, and global commerce introduced even more complexity to Indonesia's DNA. Traders from India, China, the Middle East, and Europe all left behind genetic footprints. Y chromosome studies reveal that these later migrations were often male-driven, while the maternal DNA remained largely unchanged. This means that despite foreign influences, the core genetic identity of Indonesians remained intact, a testament to the strength of their ancestral roots. But what does this all mean for modern Indonesians? Every Indonesian today carries within them a living history, a mixture of ancient hunter-gatherers, bold seafarers, and powerful traders. It explains the stunning diversity of features, cultures, and traditions found across the archipelago. And thanks to genetic research, we are now able to trace these movements with incredible precision, unlocking the untold stories written in DNA. Indonesia isn't just a country. It's a biological masterpiece, shaped by thousands of years of migrations, resilience, and adaptation. Its people are a bridge between the past and the future, carrying within them the legacy of some of the greatest human journeys ever taken. For centuries, a hidden boundary has shaped Indonesia's genetic makeup, separating populations in a way unseen yet undeniable. This divide is not man-made. It is nature's own border, known as the Wallace Line, a silent force that, for thousands of years, dictated who mingled and who remained isolated, influencing not just language and culture, but the very DNA of the people. In western Indonesia, Sumatra, Java, and Bali, the genetic footprint closely resembles that of mainland Asia. Thousands of years ago, the first migrations from China and Vietnam carried genes, traditions, and languages that would shape much of the Western Indonesian identity. They farmed the land, built organized societies, and expanded their influence through trade and conquest. But on the other side of the Wallace Line, a different story unfolded. In the eastern islands, including Maluku and Papua, the DNA tells a separate tale, one of deep ties to the ancient peoples of New Guinea and Melanesia. The genetic signatures here are older, more distinct, and relatively untouched by the waves of migration that shaped the West. These people, descendants of some of the first settlers of the region, preserve traditions and features that set them apart from their Western counterparts. For thousands of years, this divide remained intact, despite the seafaring capabilities of Indonesia's many civilizations. Why? Because the Wallace Line is not just a scientific concept. It represents a stark ecological boundary. To the west, the forests of Sumatra and Java teemed with tigers, elephants, and rhinoceroses, species common in mainland Asia. To the east, the landscapes were vastly different, home to marsupials and bird species, more closely related to those found in Australia. This environmental contrast influenced migration patterns, making intermixing far less common than one might expect in a land dominated by the sea. However, the Austronesians, the master navigators, eventually began crossing the Wallace Line, bringing cultural and genetic exchange. This marked the first true blending of these once separate populations. Yet, despite these interactions, the genetic differences between West and East Indonesia remain deeply ingrained. Even today, scientists can easily distinguish whether a person's ancestors came from Java or Papua simply by analyzing their DNA. What makes this all the more fascinating is that these distinctions are not just about genetics. They extend into language, traditions, and even societal structures. The diversity that defines Indonesia today can be traced directly to this ancient natural border, a silent force that shaped an entire nation's heritage. The Wallace Line is more than just an invisible boundary. It is a living testament to Indonesia's unique evolutionary journey. It reminds us that history isn't just written in books or carved in stone, but encoded in the very DNA of its people. And as science continues to unlock new discoveries, one thing is clear: Indonesia's genetic story is far from over. For thousands of years, the seas surrounding Indonesia were not barriers, they were highways. The Austronesians, a group of master sailors and explorers, used these waters to spread across the vast archipelago, leaving behind a genetic and cultural legacy that still shapes Indonesia today. Unlike earlier settlers who arrived on foot through the now-submerged Sunderland, the Austronesians came with boats, knowledge, and ambition. Around 5,000 years ago, they set sail from Taiwan, navigating treacherous waters and discovering new lands with incredible precision. These were not random drifters. They were skilled maritime pioneers who understood the winds, the tides, and the stars. When they reached Indonesia, they didn't just settle, they transformed it. They introduced new agricultural techniques, growing rice and other staple crops that supported larger populations. They brought advanced tools, domesticated animals, and, most importantly, a linguistic and cultural system that would spread across the islands. Even today, most Indonesian languages belong to the Austronesian family, evidence of their lasting impact. But their influence didn't erase the people who were already there. Instead, they intermingled, blending with the indigenous populations and creating the diverse genetic landscape that exists in Indonesia today. In some areas, like Java and Sumatra, Austronesian DNA dominates. But in places like Papua and the Maluku Islands, traces of the original inhabitants remain strong, preserved through generations. The spread of Austronesians didn't stop in Indonesia. They continued their journey across the Pacific, reaching as far as Hawaii, Easter Island, and even Madagascar. But Indonesia was a crucial launching point, a hub where cultures met and merged before expanding further into the world. The story of the Austronesians is not just about migration, it's about innovation, adaptation, and survival. They were more than just travelers. They were the architects of modern Indonesia, shaping its languages, traditions, and genetic heritage in ways that still resonate today. Indonesia's genetic history isn't just shaped by migration and ancient civilizations. It has also been influenced by powerful empires and global trade. For thousands of years, merchants, conquerors, and explorers from distant lands arrived, bringing not only goods but also new genes that subtly reshaped the population. The Indian influence came first. As early as 2,000 years ago, traders from the Indian subcontinent brought with them Hinduism, Buddhism, and a wave of cultural and genetic exchange. This is why traces of Indian ancestry can still be found in certain Indonesian populations, particularly in Bali and Java. The impact wasn't just genetic. Indonesia's ancient kingdoms, like Srivijaya and Majapahit, were deeply connected to Indian culture, leaving behind temples, scripts, and traditions that persist even today. Then came the Chinese. By the 10th century, Chinese merchants had established deep trade ties with Indonesia, settling in key trading hubs like Java, Sumatra, and Borneo. Over time, intermarriage between Chinese settlers and local Indonesians created distinct communities, contributing to the diverse genetic landscape. The Peranakan culture, a blend of Chinese and Indonesian traditions, emerged as a result, showcasing how trade led to cultural fusion. The Middle East also played a crucial role. With the spread of Islam in the 13th century, Arab and Persian traders brought not only religion but also their genetic legacy. Many Indonesian sultans and ruling elites traced their lineage to these foreign merchants, further blending the DNA of the archipelago. Even today, Y chromosome studies reveal Middle Eastern ancestry in certain Indonesian communities. But the biggest global impact came with European colonization. The Portuguese, Dutch, and Spanish didn't just control trade. They left their own genetic marks, albeit in smaller proportions. The Dutch East India Company ruled Indonesia for centuries, leading to intermarriages and introducing European genes into the population. While their influence was more political than genetic, traces of European ancestry can still be found in some Indonesian families today. Despite all these influences, one thing remains clear. The core identity of Indonesians has endured. While genes from India, China, the Middle East, and Europe have left their mark, they did not erase the deep-rooted Austronesian and Papuan heritage. Instead, they enriched it, creating one of the most genetically diverse populations in the world. Genetics is not just about tracing ancestry. It is also shaping the future of medicine in Indonesia. Scientists are now using DNA research to unlock life-changing medical discoveries, creating treatments tailored specifically to the genetic makeup of Indonesia's diverse population. One of the most significant breakthroughs involves genetic diseases. Thalassemia, a blood disorder that affects oxygen transport in the body, is more common in certain Indonesian populations due to inherited genetic mutations. By studying the DNA of affected communities, doctors are developing more precise diagnostic tools and treatment plans to combat this life-threatening disease. But the impact of genetics goes beyond rare conditions. Researchers are uncovering genetic markers that influence how Indonesians respond to certain medications. For example, some groups metabolize drugs differently, making common treatments less effective or even dangerous. With this knowledge, doctors can personalize treatments, ensuring that medicines work as intended and reducing harmful side effects. DNA research is also helping in the fight against infectious diseases. Scientists have discovered that some genetic variations make certain populations more resistant or more vulnerable to viruses like hepatitis and dengue fever. Understanding these genetic defenses is paving the way for vaccines and treatments specifically designed for Indonesian communities. The future of medicine is heading towards precision healthcare, where treatments are customized based on a person's genetic profile. This means fewer medical risks, more effective therapies, and a healthcare system that truly understands the needs of Indonesia's people. As genetic research continues to expand, it holds the power to transform medicine, making it more effective, personalized, and accessible than ever before. Indonesia's genetic diversity isn't just a relic of history, it's a key to the future of science and medicine. As research advances, the knowledge hidden in DNA will save lives, improve treatments, and reshape the way healthcare is delivered across the nation. Indonesia's DNA isn't just a record of the past, it's a roadmap to understanding the future of humanity. With each genetic discovery, scientists are uncovering new insights about ancient migrations, human evolution, and the survival traits embedded in our genes. But beyond history and medicine, what else can Indonesian DNA reveal? One of the most astonishing discoveries is how Indonesia's genetic diversity holds clues to the broader story of human migration. DNA evidence shows that early humans traveled through Indonesia on their way to populate the Pacific, making it a critical crossroads in human history. This genetic blueprint confirms that Indonesia was not just a destination, but a launchpad for some of the most daring journeys ever undertaken by early humans. Genetics also provides a deeper look into physical traits unique to Indonesian populations. Why do certain islanders have exceptional diving abilities, allowing them to hold their breath for minutes underwater? The answer lies in genetic adaptations that have been passed down through generations of seafaring communities. These evolutionary traits showcase the incredible ways in which humans have adapted to their environments over thousands of years. Even cultural traditions have genetic links. Studies show that the way Indonesians process food, tolerate certain diets, and even their resistance to some diseases are tied to inherited genetic markers. This means that beyond shaping identity, DNA actively influences daily life in ways most people never realize. But perhaps the biggest revelation is that Indonesia's genetic diversity is still evolving. With modern migration, intermarriage, and lifestyle changes, the DNA of future generations will continue to shift, carrying forward an ever-changing legacy. Scientists believe that studying this evolution will help predict future health trends, allowing us to adapt medicine, nutrition, and even public policies to meet the needs of Indonesia's next generations. Indonesia's DNA isn't just a static code. It's a living, breathing story of resilience, adaptation, and transformation. From ancient migrations to modern discoveries, it holds secrets that are only just beginning to be unlocked. And as science advances, who knows what other mysteries hidden in Indonesian DNA will be uncovered next?